index laws 4 and 5, products of powers and fractions, and some further applications. As always with our index laws, we can expand an example to see what our shortcut will be. Here I have a product. Look, I wrote this the wrong way around. This should be powers of products and fractions. Sorry, powers of products and fractions. My bad. This is a power of a product. Product is multiplication, x times y. This is a power of a fraction, a division. xy, or x times y cubed, will be xy times xy times xy, and this is x times y. I can rearrange multiplication, so this is really x times x times x times y times y times y. This is x cubed times y cubed. And I could get rid of that times sign there if I wanted. The product in the brackets to a power, each separate factor gets raised to that power, x cubed times y cubed. And the same with the fraction. Let's expand it to have a look. This is 2/3 times 2/3 times 2/3, 2/3 cubed. When I'm multiplying fractions, multiply the numerators. 2 times 2 times 2 is 2 cubed. Multiply the denominators. 3 times 3 times 3 is 3 cubed. The parts of the fraction to the power became the numerator cubed over the denominator cubed. So, law 4, raising a product to a power. If I write my product as a times b to the power m, this will be a to the m times b to the m. Oops! I'm sorry, I wrote it in the wrong spot. So not my day, is it? And raising a fraction to a power, if I've got a over b to the m, that will be a to the m over b to the m. This is definitely law 5. This is law 4. Sorry about being in the wrong spot. Now there's a couple of things that's important to note. When I get an answer when simplifying with index laws, if I only have numbers to powers, I would leave my answer in index form unless they asked me to evaluate. If I end up with numbers and letters in my answer, such as, for example, when I expanded x over 3 squared, and I've got a power of a letter and a power of a number, then it is most correct to take your power of any numbers into its evaluated basic number form and leave your letters in index form, because of course there's nothing else you can do. So I'll talk about that little characteristic a bit later on. So for example, expand using index laws. We're hopping right into a more tricky one. Here I've got products and a fraction raised to a power. So it can be easier to say, look, I will do the top to the power 4 in brackets and the bottom to the power 4 in brackets, and now this is index law 4. Every factor to the power. Negative 2 to the power 4, please remember, you will have to write your negative in brackets, because if you are raising a negative to a power, it must be all in brackets to show that it's the whole negative to the power. And times a squared to the power 4, that's index law 3, remember? Multiply your powers, I've got a to the 8. 3 to the power 4, b to the power 4, c, I've got c cubed to the power 4, multiply your powers, or your indices, we'll get C12. Then I've got numbers to a power and letters to a power in the same answer. I evaluate my number powers and leave my letter powers as they are. Negative 2 to the power of 4. If you need to use your calculator, you must put your negative in brackets to the power 4. 16. I've got 16A8 over 3 to the power 4. Use your calculator if you need to. 81. B4, C12. Check if you can simplify your fraction, which you can't there. Remember, you can always check that. 16 over 81. And if it doesn't simplify, you can't simplify it. So, next question. Evaluate by writing as a fraction. This is a cute little aspect. Fractions are almost always easier than decimals. Let me show you. 0.4 as a fraction is 4 over 10, and I'm cubing it. Can I simplify that fraction? Absolutely I can. This is 2 over 5. Still need to cube it. And this is a power of a fraction. This will be 2 cubed over 5 cubed. And 2 cubed is easy. It's 8. 5 cubed is easy. It's 125. You've evaluated a decimal to a power much more easily than you would have if you'd left it as a decimal. Cute little application of the index laws. And another application of the index laws. This looks a bit confusing when you first start out. It's a multiplication of powers, but we've got different bases and the same power. When you look at it, this is actually a reversal of index law 4, because index law 4 says a times b to the m is a to the m times b to the m. A to the m times b to the m says that I can take the base numbers, put them in brackets and multiply, and raise to that identical power. Remember, of course, that if I'm multiplying a number and a letter, I would put my letter first. 4 times a to the power 3. I don't need that times sign. I've got 4a to the power 3. I've written this as a single power.